so 1.1 formula list, I'll do write all the formulas and then we'll do those questions. So the first is just a vector. The vector on a reference plane is a point on a reference plane which is attached with the 0, 0. Right? For example, 3, 2. Now we can add vectors, we can subtract them, but last time we didn't learn how to subtract the vectors, right? Did I teach you?
No, we didn't.
No. So now let me write down how to add them. If you have two vectors like that.
You add the x's and the y's, right?
Mm-hmm.
Add the x's that add.
That's right. For example, let's assume we have this vector with 1, 3, right? And the sum of these two vectors, let me call it u, and that's v. So u plus v. So you add those components, x components with x and y with the y. So we do 1 plus 3, 4. 3 plus 2 is 5. So the sum of u, v is that, 4, 5. So like 1, 2, 3, 4. And so it's going to be in the middle. Right here. So we already know that this is going to be the diagonal of this parallelogram that we have there, right? So we have, I shouldn't be making those lines, otherwise disappear. So this vector u, v, and the sum of them is in the middle, u plus v, and it's represented by this point, which is 4, 5, the same point, 4, 5. So this distance is 4, and this distance is 5. Makes sense to you, right? Mm-hmm. In the same manner, we can subtract them. So sometimes they're gonna write on a reference plane. Sometimes they just give you the vectors like that one and this one. So you'll be just adding them. So the subtraction of the vectors is gonna be the another diagonal. For example, let me draw some reference plane. And I take this vector, which is 5, 1, 1, 2, 3, 4, 5, and I take a point. Let's say we have 2, 4, right? So right there. Now the sum is gonna be in the middle, and we know that sum is gonna be this is 2, 4. So sum of them is 5 plus 2, 7. And then 4 plus 1 is 5. That is the sum of them. So it's going to be in the middle. And let me complete the parallelogram. Okay. Well, I'll make just with the hand. So it's going to be in the middle there. 7, 5. Now the important thing is the difference of u and v. U plus v is that. What would be u minus v?
You subtract the x's and then subtract the y's?
Yeah, we do that, but geometrically it's going to be u plus minus v.
Okay.
Now, what is minus v? Minus v means you just change the coordinates of v. So v was, in this context, v is 5, 1. And the negative v is going to be negative 5, negative 1, right? So you change their coordinates with negative sign. Now negative 5 is going to be here, and negative 1 will be right there. So the negative of that is going to be exactly in the opposite direction. So it would be like, I don't know why it's not. Okay, I'll use that one. Well, just, but you understand, right?
Mm-hmm.
Slightly off. Right there. So minus v is that. Now we're adding minus v to u. If you add minus v to u, what would we get as a resultant? U and minus v. So sum of u and v is gonna be a diagonal of this parallelogram. So we complete a parallelogram, and its diagonal will be right there. Right? That's what we learned. We learned that the sum of any two vectors is gonna be a diagonal geometrically. So it's gonna be there, right here. So this vector is u minus v. And I told you two vectors are same if they have the same direction and the length, the magnitude. So this vector is same as this one.
Oh.
Good?
Okay.
So we got this diagonal. Therefore, this is also u minus v, because this vector is exactly the same vector, same copy, because their directions are same and the magnitudes are same. So u minus v is that, and the sum of them is in the middle. This is u plus v. Good? So now you're going to remember that the difference is going to be in opposite direction, and the sum is just originating from the same point. So this is the sum of these two vectors, right? So we learned that if you have two vectors, sum is right here, and the difference is going to be here. Now it's important. Let me write it down there. So if you go from u if you do u minus v, then the direction is going to be towards u. If you do v minus u, the direction is going to reverse.
Okay.
If you go towards u, the arrow is going to be towards u, because we are subtracting v from that. And if you do v minus u, then it's going to be a flip of that, and it's going to be in this direction. You see? We'll make a parallelogram there, so diagonal is going to be right here, going towards that direction. So now let me call it, this is a point, that is b point, so that's o. So if you do o, if you do ab vector, that is going to be from a towards b, right? A to b is going to be ob vector, which is that, minus oa. So if you call it u, that is v, then we're going to write uv vector. Sorry, v to u, because from v towards u is going to be u ob is u, yeah, minus v. So you're going towards u, that's why you're writing u first. Just you look at where you want to go. You want to go from u to v to u, so you have to write u first. So if they do uv, then now you're going towards v, so you do v vector minus u vector. So this is really important, or this thing. Makes sense to you, right?
I think so.
Any question, I can elaborate it more, in a more better way if you
I
want.
think maybe like once I see it in like context of like a
Mm-hmm.
question. it
Let
would
me.
help.
The question they're gonna ask you is gonna look like, point A is 3, 2. B point is -1, 7. Find a B vector. So this is the question in the context of the differences of the vectors. Now you can draw that if you want on the reference plane, or simply imagine that I have, let me do it roughly because it's going to be more better rather doing without vectors. 3, 2. Approximately there, right? And -1, 7. Let's say there. And that is A. This is B. And you have to do, you have to find A, B. Now, from A towards B. Right? From A towards B. And we already know that we're going towards B, so as we learned in this example right there, if you want to go towards U from V, you're gonna do U minus V, because negative of V is that, and U minus V means U plus minus V. So you add U and the minus V, so we're gonna get U plus minus V, which is that. So U minus V is going towards U. But if I do V minus U, then I have to, let me write it down because I think it's important to clear this thing out. Now I do V minus U. V is right there. Where is the negative U? Negative U is going to be right here. Right? Negative U. That's the extra part. Let me use another pen because I don't want to mix these two things. Negative U is right here. And plus V, which is right there. This vector. So the sum of them is going to be this diagonal right there. I don't want to make the parallelogram, but it's going to be like that. And this vector now is V minus U. And you see this vector and that vector, they're same. If your arrow is towards that direction, then this is V minus U. You're going towards V. And that is going towards U, and I already did it there.
Okay.
Makes sense to you. Good. So we learned so far we have to write a vector towards which we are going towards B, so I write OB, or right, every point is a vector, position vector, so we do OB minus OA. If they ask you to find the sum of them, then it's going to be this diagonal. The difference is that diagonal. So we do substitute the values. OB is now -1, -3, and then 7, -2. So we got -4, 5. Good. So this vector basically, now you'll ask me like how it's that vector. I'm gonna show you how this vector is that vector now. We find the position -4, 5. -4 is gonna be somewhere here, and then 5 will be up here, right? That was 7, so 5 is gonna be right somewhere here. Yeah, 5. And -4 hypothetically somewhere here. So this point is referring to this vector, which is same as that one. So AB vector and this vector, they're same. So your answer is going to be that.
Okay.
because we can move them anywhere. You can just pick and move it anywhere, so they are same. Good. So now we know the geometry of the vectors, how we add them and subtract them. So now the next thing is what would be the sum of these two vectors? From here to there, and then this vector is starting from here and going up to this point. Let's call that is u, and this is w. So it's the same method that we were doing before. We just pick this vector and replace it there. So we make exactly same vector here with the same length, and we do u vector, and we are interested in u plus w. So u and w, now the sum of u and w, because they're originating from the same point, is going to be right there, right? Now I can replace it there. I mean, you can pick and put it there. So this is u plus w, and this is also u plus w. Therefore, if you have two vectors, let me erase it now. So we learned that u plus w, if they're going in this direction, you just go from here to the tail of the u. So therefore, if we have this vector, that vector, this vector, sum of all of them will be right there, resultant.
Okay.
The displacement vector. So let's say a vector, b vector, c vector. So the sum of a plus b plus c is going to be right there. Right? And I explained to you, we just replace it right there, and then the sum is going to be right here. So this is something extra, and probably you will not encounter a lot of problems related to that, but geometry is important in order to succeed and score really good on this course. So that's good. Now we completely understand that idea, and the next thing is the distance between u and v. I will just write down the formula because I think you already know the concept really well. So the distance between u and v, how do we do that? We, for example, my u is 1, 2, 3. And 5, 2. 1, 2, 3, 4, 1, 4. Now the distance between these two vectors, u and v, basically, did they do the length of vector? Yeah, right there. You have a u and you have a v. So what is my u? U is a point. Let me call this is my u. This point is u, and this vector is represented by the point. So every point is somehow a vector. Point and vector is the same kind of thing. So that is u, and v is this point. V. So that is u vector, and this is v vector. And the distance between u and v, that's what they're finding, right? So what we do, we make a small triangle there. Now we have to find this side length, and according to Pythagorean theorem, it's gonna be square root of them and square root of the whole thing. So this is equals to square root of this side length. Now what would be that?
The point or the length?
This length. That is 4.
Oh, okay.
And this is 2. So this is also 2. 2. So that's 2. So 4 minus 2 is going to be that. So you do 4 minus 2 is this length, this tiny length. So that is equals to 4 minus 2. Now what is that length from here to there? You do with respect to the x components. So
5 minus 1.
yeah, that's my 1 here. So let's say, and right there is 5, and so 5 is whole thing from here to there minus 1. So that's gonna be 4, right? 5 minus 1. So you simply remember this trick that you do the differences of the x coordinates and y coordinates, and by Pythagorean theorem we do the square root of them. So we squared the small sides, and then we do the square root of that. That's gonna be the distance between u and v. Good. So we got 2 minus 2 is 2, 4 minus 2 is 2, 2 squared is 4, plus 5 minus 1 is 4, and square root of that. So square root of 20 is the, if you simplify this thing, it's going to be 2 square root of 5. So you can find any distance by using that formula. The formula is the distance between u and v is u1 minus v1, u1 minus u2 actually. v1 minus v2, and these are the coordinates of the points. So u vector is made of u1, v1, and v is made of u1, u2, sorry. Do the right u1. Yeah, I normally don't use u1, u2, but anyways, let me write here u1, v1, and that's u2, v2.
Okay.
So differences of the x components and differences of the y component squared, and then square root of whole is the distance. Now, what else they can ask? The unit vector, you already know how to find the unit vector. So that is the scalar multiplication. That's the sum of u and v. Now let's do the question that you have, you want to ask. So the problem is, and we have to perform the indicator. So we have to do u is -9, -7, 2. So -4u is going to be -4 times by the u vector, which is -9, -7, 2. And we do 4 times 9. Right? Minus sign, and then 9 times 7 plus 28.
Is it 4 times 7 or 9 times 7?
9 times 4, and then 4, like 4 multiplied with all those. Yeah. So it'll be 28, and then -4 times by 2 is -8. So you multiply -4 with all of them.
Right.
Now that is that. So
would these both turn into positives? So
yeah,
this is -10
you're
squared.
right. You're right. I'm doing a mistake. There should be a positive sign because both of them are negative, right?
Yeah.
So all positive. Last one turns in. That's right. And next, r minus t. Now we do how to do the differences. We already know that. It's pretty simple. So let's say r is -4. And t equals to 3, 1, right? So we do r minus t. So you're going to do x component of r minus t component. minus the x component of t. Let me write down both of them. This is r minus t. T is,
3 and 1.
yeah, so negative 4, negative 3, negative 7. 5 minus 1 is 4. So that is that.
Yeah, these are all like the homework.
All right. The third is the length of our vector. And we learned that the length is going to be, for example, what is our r is minus 3, 3, yeah. And the length of this vector minus 3 and plus 3, sorry. So it's going to be right there. And its length is by Pythagorean theorem, you do the square of that.
Right.
And that. This is a x component,
So
that
it's
is a y
3 and
component.
3.
Very good. So we squared x components, y components, and do the square root of that. 9, 9, 18, and square root of 18. Now we can simplify that because that is that, right? 18 is 9 times. Then square root of 9, square root of 2. Now square root of 9 is 3, so answer is going to be, that's a simplified answer of that.
I don't know how to do that.
Sure.
I don't know how to get the square root symbol.
Square root, you can write so just write SQ square root, yeah, that's what they call SQT and 2. Good. SQ, I know. You don't, yeah, it's alright, good. Probably you can, they're gonna mark them, right? So
Yeah,
obviously,
like
so,
separated, I guess.
alright. Then W minus U. W vector minus U. W is 8, 0, minus 2. Minus U is, what is U? 2, 6?
2, negative 6, and
Negative 7. So 8 minus 2, 6, 0 minus 6 is plus 6. Minus 2 minus minus, that is plus 7. So we got plus 5. Is it right? Minus 2 plus 7. Minus minus is 7. Right. So we got 5 there.
And that's the final answer?
Yeah, that's no, that's not a final answer. We also have to do the length. Let's assume they ask you to find the length of that, and we already learned how to do length. In order to find length of anything, we squared all the components, add them, and we do the square root. So that was the length of r. So the length of this vector, which is looks like that. So length of this vector is gonna be square root of all of them. So that is a generalized form of the Pythagorean theorem. 36 is going to be 72. 72 plus 25.
I always have to like write things out. I can't do math in my head.
Alright, so let's do there. 7. I don't know. So that's a prime number, so you just keep it. So square root of 97.
So instead of finding the length of this and then the length of that and then subtracting them, you can just find the difference.
That's
between
gonna be
them and
wrong.
The length of that.
It's not distributable, so we cannot find length of them individually and then
Okay.
subtract. That's
So
gonna
you
be
have
wrong.
to find
Yes.
the line first and then just the length.
Yeah, that's important. We do the difference, and then so this thing is gonna be completely different. You're finding length of W minus length of U, and geometrically it's gonna.
Those would be these and not like that.
Yeah, yeah, that's true. So you see that's U, that's W,
Yeah.
and the difference is right here.
Instead of those
Yes.
two.
So length of this vector is not equal to the differences of their lengths, right?
Okay. Yeah, that makes sense.
So that's not true. All right. So, anyways, that is that, and next is Now we have to find unit vector of, let's say we have u vector and 3, 2, minus 1, and the length of this u vector, we squared all of them, and then do the square root of that. Now this is the length of the u vector. So we got 9 plus 4 plus 1. So 9 plus 4, 13 plus 1, 14. So that's the simplification of that. Now you just keep it as it is, but we have to find a unit vector of u. So sometimes they write u hat. Now what is a unit vector of u hat? Let's assume we have a 3D space and this point is in 3D. I assume hypothetically, let's say this is the vector 3, 2, negative 1, and its length is not 1, its length is this. So if you divide its length with itself, it's going to be a unit vector. So 3, 2, minus 1, if you divide it by its length becomes 1, right? So the whole vector you divided by its length, then it's going to be 3 over square root of 14, 2 over square root of 14, and then negative 1 over square root of 14. So it's a scalar multiplication. You multiply this fraction with all those components. You multiply it by 3 and then by 2, and then you times it by negative 1. So we got a vector, and this vector is unit vector of this vector. So they have same direction, but the length of u is that, and length of this vector is 1. Why 1? Because we already divided the length of that by, we divided it by length of itself. So if you divide any vector with its length, it becomes a unit vector. That means its length becomes 1. So you can write it later on because these are saved. You can watch them anytime, right?
Okay.
Now the next thing is, let me make sure that good. 3.
I'll just fill it out after, as long as it doesn't time
Good.
out and
Yep.
give me 0 or something.
So what is the time for
It doesn't. It just says it's due tonight at 11:59.
okay, so now
We have this room booked in a few minutes, I think.
all right,
All right,
thank you. Okay, so how many questions do we?
There's none, but it's okay. If
All right, let's
we
go
only
over
have,
the
like,
next
4
one.
minutes,
Yeah.
so, where did we leave off? We just did this one, so.
So number 6. So find the unit vector having the opposite direction. Now this vector is, let's call that is a u, and a vector opposite to this one is going to be negative of that, right? So you put negative sign, and now the negative sign goes in negative 4 and 3. So if that is u, negative u is going to be in this direction, right? So what we have to do, we find the length of this vector, reverse the direction, and then divide its length divide this vector with its length. So we're going to do find the length of u, and the length of u is equals to 4, 9, right? Sorry, 16 and 9, 25. So 16 and 9 are 25, and we got 5 there. So so we divided by this vector by its length. So minus u divided by 5 means 1 over 5. Good. So negative u is that, we divided by its length.
So just like the previous question.
Mm-hmm. But this time we are doing in an opposite direction. So
Because it's the opposite.
yeah, so rather dividing u with its length, you divide its negative with its length. Negative is gonna flip the direction,
Right.
and then you divide with this length. So whenever you divide anything with its length becomes 1. For example, if my height is, let's say, 5 feet 6 inches, I divide it with the same number, what I get 1, right? So that's the kind of logical statement. Divide any length with its any divide any object with its length, then the length of that is going to turn into 1. Find the vector that is equivalent to the direction line segment from the first point. So a vector is starting from this point and it's going towards -7, -6, 8, right? Like that's A, that's B, from A to B. And we already learned how to do that. In order to find AB, we are going towards B, so we do OB minus OA. Like, let's say this is the reference plane, this is my OA, that is my OB, so we do OB minus OA, which is gonna be the difference of that. Good?
Yeah.
Alright, so we do the differences of them, and it's pretty simple.
So it's just like each one of these minus.
Good, we subtract them. -7 minus 0, -7. -6 minus, it's gonna be -1. 8 plus 9 is,
Negative. Oh wait, never mind.
yeah, because negative turns into positive, so that is that.
Okay.
And
I don't want to keep them waiting.
alright, so we will continue working on the problems. You can go to www.londonmathsolutions or my YouTube channel for watching more videos. Thank you.